Okay, so this is going to be a pretty informative video. Um, I'm working on a personal project. I'm trying to create a version of Hadoop, Hadoop distributed file system, and I want to do that in Ruby because I want to learn some Ruby. This basically explains everything. Yeah. This basically explains everything about what it's doing, and I'll link the video. I'll link everything in the description. But basically, yeah, I'm trying to create a Hadoop thing, and this is just my sim configuration file. But the purpose of this video is to show people how to basically use gRPC in Ruby. I had a lot of trouble figuring that out, and I don't want other people to go through the same trouble. If this video gets enough views, then I can do a way more professional video on it, but this is going to be just a really informal thing. If you're just trying to get into it, learn how it's done, then this is the video for you. If you just want to look at some screenshots, there's some code for a while, um, see what it looks like when it's done properly, just like test it out. We can like actually a open a terminal right here. If I do Ruby, this is my test for it, actually. Yeah, let me show it. I import some stuff here. I create a node, a test node. It's going to start the server right here. Very high level stuff. I actually wanted to have a TLS connection. TLS stands for Transport Layer Security. It's what is exchanging all the encryption keys so that you can actually encrypt your traffic, having certificates so you can like validate that the person sending something is indeed that person. I wanted to have that, so I had to figure out credentials things, figure out where I'm connecting to, and then this just creates some data, test data. This connects to the server and it receives some to receive some chunks, send some chunks there, and I get a response. I kill the server thread and put a response there. Very informal. I do apologize for that very terrible explanation, but test con local just to prove that this does work. Here we go. I was able to create this. I was able to create a node. I printed out the node's information, so I have a localhost 0, uh, an ordinal 0, is it the if it's a primary node, which is true, and then the name node configuration. Name node configuration ba is basically just the file from the simconfig. You might notice the word cube here. I plan to make this a Kubernetes deployment where it's just a giant Kubernetes deployment where I have a I basically simulate a cluster, just like an actual Hadoop is going to have name nodes, data nodes. It's going to have an interface node where the user will hopefully have a GUI and be able to actually upload files and retrieve files from the file system. It's nothing serious. Not trying to make this like a production thing. Just something fun to do and to help learn some stuff. Um, but it's basically printing out all that here. We go back. Oh, hi, Lila. Yeah, there's a cat on me now. But and if we go down, you see that we're gonna make some data. Yes, yes, Lila, I'm talking. We're making some data, a list of test chunks to send. Is going to send some test chunk data because one thing you should know about gRPC, it is not if you really want to be sending files and you're trying to make this an app you can sell to people, it's a bad idea to do it in gRPC. This is mainly for like sending messages, but I wanted to cheese it anyway. So I created a system where I'm designed a system where you'll be able to send files as little tiny chunks. So basically just doing T TCP just at the application level. Well, not even application level. This is what session level in OSI. But yeah, basically just doing TCP in a gRPC thing manually, and that's fun. But this is a test for it. I create a test chunk. This I'm gonna get into what this is later. and also for this too, because this is very important. And then, I have to encode the data. So the response is going to send that information to the server connection. It's going to receive some chunks, and we're going to send. And since I have a list of these chunks, going to send this one by one, right? Um, as you can see, what the server is supposed to do is that once it receives the chunks, it's supposed to send a response back. And that response is going to get printed out of the terminal. As you can see, it was indeed printed out into the terminal right here. You see the chunk transfer, receive chunk response, and everything is down here. Uh, I wouldn't fake it for YouTube because I had so much trouble just getting this working. This is not even the final. It's not. I'm not even close to this being done. I just had to get this basically working, right? So, now that this is proof that it works, you can also check out my GitHub. I will put my GitHub link in the description. But now that we know this works, let's get into what I had to do to make this work. This is my project structure. You don't have to do this. I did this because this is how I like to just do things. I have everything for the data node here, interface, and name node. I have everything in different in folders because I'm going to eventually turn these into Docker containers. So I'm going to put a Docker file in each place and then, upload it to my personal Docker page. So I'll be able to pull it down on Kubernetes and create the deployments. Data node and interface, I just have some really basic boilerplate there. The name node is really the only one that's even partially complete. And at the end of the day, it's going to look more like the name node than the other stuff. This is just placeholders right now. VS Code, that's just my settings. You know how it is. HDFS grpc. This is where a lot of the magic happens. Wait, but before that, this setup folder, this is going to be where I'm going to do some order generation because, as you know, if I'm doing a Kubernetes deployment, that would mean I have to write out the actual deployment specs, service specs, and I'm not doing that. So I'm going to have a Ruby script that's going to do that for me. Anything I can do in Ruby, I will. Trust. But here is something that I'm not doing in Ruby. Well, I lied because I am doing it in Ruby, but the other way you think. So first, I guess I'll talk about these real quick. Generate pronto. The actual type of file doesn't matter. These essentially do the same thing. One is just useful for Windows. One is useful for Linux. So let's go to the Windows one because it's more readable. This is just for own personal preference. It gets the directory of where the script resides. So basically, querying itself and saying where am I, and then getting prepared for that because that's going to determine how the rest of this goes. I'm going to have a definitions directory, which is where I'm going to be hosting all the proto files right here. I'm going to have a services directory, which is where I'm going to be hosting what's generated by what the script I'm going to do. And then I'm going to have to replace script because to have it like this, where the protocol buffers, which is why it says PV right here, and the services have it close together, I don't think that's standard practice. So I have this cheeky little Ruby file that is going to fix the other Ruby files. Yeah, I love Ruby. So basically, creates the service directory that doesn't exist, self-explanatory. It's going to see if it exists. If it doesn't, it's going to create it. Next is going to get all the definition files. Uh, we're going to basically get the child items by filtering from the proto. So everything that's a proto file in here, we're going to get it. Now there are only proto files in here, but the reason is like this is because I have a generic proto file as well, and I don't want that to be in here. And now we're going to basically loop through all the files. We're going to say that we're going to process the file. We're going to see the file where it has services files generated. So we're basically going to see which file is older. Is like, how make and CMake work, how they will check if the generation you want to do has already happened. So if the generated output is actually younger than the source files, CMake is going to be like, oh, this is already generated. I'm going to skip over it. That's what this is basically doing. So it's going to get a child item. Um, We're gonna check this out if it's outdated, right? If it's not outdated, then or if it's not outdated, then or if the files just don't exist, we're going to actually create the protocol buffers. Since I'm using Ruby, I use the proto C that was packaged with Ruby, but you can also use your own proto C for this. This is where all the definitions comes in. We're going to look in the definitions folder. We want the Ruby files to go into here, the grpc buffers to go into here, and we also want to generate a core message.proto file. Well, we also want to like look at the core message.proto file because this is going to have some core stuff that's going to be split among these, and that's just going to be like standard GPC stuff. But we also want to get our own file name, right? We use full name here so that we can tell the process exactly where this is. Um, After that, we're going to have to generate, we're going to have to basically run a replace script among these files. So basically use the base name of this, which you can see how the base names are similar. Data node is very programmatic, very useful. We're basically going to get those, and then we're going to run the replace script against them. If we go to the replace script right here, we can see that it's going to take the file as a command line argument, going to read all the lines, and then it's going to check if each line has a grpc in it. Now, it's going to have a require line because in require lines, if we were to open this, we'll see this when it's generated will be required, right? It also says do not edit. We're ignoring that. We're ignoring that. Yeah, but this is a require line. So we're going to see if it has a require line. We're also going to see if it has Google or gRPC in it. Because if it does, chances are that is a require that we do not want to change. We only want to change the ones that are we custom made. So if all those pass, we change required to require relative, which will let the Ruby know that we're not looking in, where you usually look for like installed gems. We're looking in the actual folders, right? Is looking like relative to where the actual folder is located. Excuse me. So we're gonna do that, then we're gonna write everything back to file, and that results in this. And that's a really good, easy way to do that. You can steal that if you want to. I have an MIT license on here. Just don't monetize it without me. I want to get a cut of that, you know. So that's basically it. That's basically it for that. Generate proto shell is basically the same thing, but made to work in Linux, as I said. Um, and now we can get into the profiles. So let me close all of that. Protofiles is basically just gRPC at its finest. Um, I did a lot of research. I did my best to make this as close to a good production, a very secure, well thought out proto setup as I could. But if you don't know, with protos, and let me also like bring up under this one, for example, a proto file has the following. You declared what syntax you're using, so proto knows what it's working with. If you want to put this into a package, which is kind of like namespaces for C sharp and other languages, then you can. You use import to import other proto files into here so you can use their definitions. Um, and then you declare what your service is going to be. It's a good practice to name your service the same name as your file or the other way around. You just have everything lined up. And then good commenting to make sure everything is like all neat and orderly. Also, proto C actually uses these comments to sometimes format what it generates. So it's good to have them regardless. You can declare your RPCs or your remote procedure calls here. Receive chunk, for example, this is a chunk transfer service. So basically, how described, uh, me basically simulating TCP at the session or the application level is basically going to divide the data I'm sending to chunks. We're going to get a stream of them. A stream is basically a continuous connection where you're getting one of a data type after another. You're not just getting one, you're expecting many until the connection is closed. And then the server is going to receive a chunk response. That is one thing. I found that writing every everything as if you're going to attach a server to it is the best way to go about it. I didn't explain that right, but if I were to go back to if I were to go here, right? I once I have this server connection, this is a connection to the server. So I can use this connection to call any remote procedure call that I want to. So it's good to write procedure calls like the server is going to be before it in a sentence, and you're writing it like you're saying a sentence. So I want the server to receive the chunks of data that I'm sending, right? So I'm going to write receive chunks here because the server is receiving chunks from the client. And then it's going to receive a stream of chunk data and it's going to return a received chunk response. And I think that kind of like mindset helps you write really good, understandable remote procedure calls. Streams, yeah, I think I explained that already. And then this is just means that you're just sending a single item. Now, once you define, it's good practice to define your service first and define everything that makes up the service below it, the messages that make up the service. Your message is going to be what you're sending. Imagine it like a funky JSON structure. Like it's going to all be converted to JSON later. Like JSON, you can define keys right here. In this case, I forgot what they're actually called in grpc, but these will be the names of the things that you send, the little bits you send, and you can define the expected type, the data type right here. You can have primary types, primitive types, and you can also have more complicated types too. And then you can have user-defined types. We can have which are just other messages encased in messages, right? So in this case, I have a check ID, because you gotta know what order you're going to be rearranging this into later. A checksum to make sure I got it back correctly, and the last chunk to indicate if this is the last chunk, right? Next you're gonna have the message data, right? This actually is a composite of smaller messages. As seen, you see chunk info is in here, but it's also session info, which is you don't see it where it's defined. This is what is coming from the import. So if you go here, you see that session info is right here. And I do this because I'm going to use session info in a bunch of other protofiles. So it's good to keep it somewhere where it's all somewhere in one place, right? And then bytes. Bytes, self-explanatory. I'm just saying the bytes of the actual data itself. Um, Another good formatting thing is to do regions. Regions signify regions. I actually don't know what definition for a region is. I'm not even sure if it is a definition, but it's where you can list things that are dedicated to something. So I use regions to just divide up my file into and by what remote procedure call that the message pertains to. These are not in a region because they're pretty general, but these are because they apply to specific remote procedure calls, right? So this is for receive chunks, this is for send chunks. And I do that for basically every file. You have the data node right here is more complex. Interface node, this one has an enum, and enum basically specifies a correlation. You know, enums are probably if you're coding in Ruby, you probably know what an enum is. I hope that wasn't too much of a generalization, but yeah, number correlates to a specific status here in this case, right? And then you see the regions for name node alive where it correlates to, basically. Um, Name node, same thing, more complex because there's more remote procedure calls, but is at its core the same thing, you know. And that's the first part. But now we get into the actual part, the point of the video, which is okay. How do we do this in Ruby? Well, now that I've written all these, I'll basically run this file, which, but in actual case, you basically just run this command to generate your desired procedure buffers in Ruby, right? But I automated it. I get the procedure buffers here. I have a procedure buffer, and then I have the procedure buffer service. This service file is what I'm going to use to reference in my actual code. So now so let's clean this up a bit. And now let's get into the name node because I've only really developed this first. This is actually what I use to figure out how I'm going to do everything. So we're going to do name node right here. This is the procedure buffer file. I'm not worried about editing something accidentally because I have Git on, so it's going to let me know if I mess something up. Um, as you can see, Git, there's a bug on my screen. There you go. This is auto-generated, as I said earlier, we already adjusted this. The descriptor data. Now, if you look in some tutorials, this will actually be different. You might see a bunch of nested information here. I don't think it's because since they updated it, they just have everything be in sort of kind of weird arrangement now. But don't worry. If you're wondering where all the information for the proto file you define is going to be in this line. It's in there, don't worry. If you scroll around, you can kind of see some indicators that it is in there. It's just looking weird. It's very computerized. This is not too important. Well, it is, but I don't know how to explain it. The name node and the important thing. So the name node, you're going to notice that it basically has every single thing you define in here. From metadata, if we go here, we can see the metadata is right here. File info data, and then we have our pings and requests and responses for grpc. It's good practice to kind of name them in a way where they're connected. So in this case, if I have a ping, I name this ping response. That way I know exactly what I'm doing. If I have a request, I add a response, and so on. And that's basically going to say the definitions for that. Next, you have the services. Services is what you're going to be actually interacting with when you're developing your code. With services, you're going to at first have your package name. This is a name node. If you go back here, we can actually see that that package name is there. Then we're going to have our name node service, and then we're going to have a class service. Um, for hints, pay attention to how this is named, um, because I don't know how Ruby exactly does it, but the names will change over time. So in this case, if you have your package in all lowercase, which you usually should, is going to title case it here, right? Is going to title case it here, and then you're going to have a kind of a word case. I forgot the name for it. It might be camel case, but you're going to have a kind of a word casing here. It's going to say name node service, which is just, and that's just going to be copying what you put here, if I had to guess. And then you're just going to have your service class, which is going to be encased within this module. So this class is a name node service specific class. It's going to include a generic service because that's what's going to use to build upon. Um, I don't know what this means. I'm going to be real. But this, you're gonna have the interesting stuff, which is your RPC calls. As you can see, uh, it's going to define different RPCs right here. It's going to say name no alive, data no alive, interface right here. You're going to notice that you have the different messages from earlier, but now they're in cases inside the name node module. And that's because when you go back here, you see that when you see the module, everything is defined at the module, at the package level. So you're going to have everything come from here. That's now, if you don't, if you have the case where you don't include a package there, Lila, do you want to jump back on again? I mean, come on then. I'm recording. Yep, there you go. Yeah, get settled. Lila just came back. She had to chill. Yeah, she had to check out the window for a second, but now she wants head pats. So I'm going to be using my left hand to move now. Okay, can this go back up? Thank you. Um, if you have the case where your name node is, what was I saying? No, yeah. If you have the case where you don't define a package, so let's say core messages right here. We scroll up, there's no package defined here. If we go to core me and if we go to core messages, we'll see that there is no module. That's because the module is supposed to be correlate to the package that you define. So everything's just going to be made at the file-ish level, right? That's going to so that we're gonna keep that in mind for later. I'm gonna close this. Okay, Lila settled down now, so I have my right hand back. Um, so now we're back here. So this is at the mod. This is we define a package for name node. So everything's going to be defined at the module level. So that's why we're reaching inside a module to actually utilize these utilize these utilize these messages. Yeah, and that's basically it for that. RPC is just being defined here, and we're going to use those. Uh, oh yeah, also stub. I forgot about stub. Stub is what a client is going to use to actually connect to the server that's going to be running the service, and that's also defined here. But I'll show you how that gets defined, or at least how I define it. Uh, so down that that's taken care of, I'm going to kind of close this now because we have all we need right here to compare. Oh, you're falling. Ow, ow. Why'd you fall off my lap? How'd you slide down? You've never slid down before. I'm trying to record a YouTube video. Yeah, go check out the window or something. Um, okay, so now we get to the name node. Here's where everything just starts to get defined. So let's open this first because it's the shortest name. Name node. This is the highest level. This is actually this is where all the action. We're gonna close this because we don't need this anymore. This is where all the action. This is where the I've repeated myself so many times. This is the high. This is where the the main logic for my name node is going to be. Now, I said I called it HDFS name nodes to remove confusion, but is going to contain a core server, which is going to have the functions of the name node services, and the data server, which is going to have the functions of the chunk transfer services. Because one thing I found was that sometimes it's just easier to decouple things, and it, right, you're able to add multiple servers to your RPC server. So you can tell your RPC server to handle core server functionality and data server functionality, and it works out, right? So let's start with the core server. Let's go here, and then is a pretty empty place right now because I wasn't using it to test anything. But as you can see, you can initialize it however you want. That doesn't matter. That's all up to you. What I do is that since I want it to be accessible to my name node, I pass the reference to my high level name node into here so it can always call its parent, right? And then this is where the actual important stuff is. Now, I don't know why I have to do it like this, but when you're writing the definitions for the actual calls in your custom service, what you're doing is that you have to write it all lowercase with each word spaced out with a underscore. And I cannot tell you why, but that I believe that is the way you're supposed to do it. When I looked it up on when I did my research, that's what I found. If I were to compare it to this, it's like it's like this message. So like every time you see something name node alive, lowercase separate everything, every word that starts with a capital letter by an underscore, and then lowercase everything. And then that should correlate to whatever the boilerplate for this had cooked up. Now the deep and now the good str now since these are all single request, single response type things, this is usually how you would define its parameters. You have the request here, and then you have an underscore call button right here. Request is going to be where the actual data is, and since it's being sent over the internet, it's going to be serialized into a JSON format that's going to be deciphered using the services. So the service is going to actually validate to know what it's expecting to receive. So it can actually process the request. And then once you do that, you would return the object that is expecting. If we were to do a heartbeat from a name node, I will take the request, I'll do whatever I need to do with it, and then what I will return is a name node. I had to go in the name node module since I added it to a I specified a package in this proto file, and then I'll want to return a name node ping response. In Ruby, you'll follow that with a new. Now, all these things right here, these are all structs in Ruby. And with a struct, you would have to define what the struct will contain and then add the actual data there. In this case, if we were to, this is a name node ping response. So if we were to go back to name node and see the response here, is expecting expecting, excuse me, is expecting a response info message called response info. So we will have to type out the response verbatim. It's easier just to copy paste it, keep it simple. Since is a struct in Ruby, is going to kind of use the same syntax as creating a hash, or as I like to call it, a dictionary, because I'm a filthy Python main. Um, is going to be a response info thing. Now remember, response info came from core messages, and core messages is not inside a package. So it's at the file level, so we could just type response info directly. And why we can do that, by the way, even though we never actually imported it into this file, is because when we import this file, is also, if we go back here, it also imports this file, which if you go back here, imports this file. So it's that chain of requires that leads us to be able to leverage that without any problem. So we could just reach through there, which reaches through here, which reaches through here, reaches through here, reaches through here, which is right here, and that's going to have the information for it. So response info, we're going to do that. We're going to call it say new because it is a new, we're going to make a new thing. And if we go to response info, so let's open up core messages, move that over here. Now we have some primitive types here. It wants a it wants a response status, which is going to be a Boolean. Or no, it's going to run or a response success. We can say true because I'm never wrong, right? And then we're going to have well, it's expecting a string called response message. Remember, is a struct, put a thing here. I really need to study Ruby. I can't explain what that is. But response message, and then we can say that this node is alive, right? And then we'll just keep doing that, doing it just like that. One thing about these return messages, you have if it is a message which contains other messages, like we saw, if it's a message that contains other messages, like we saw right here, you have to instantiate the sub messages. You can't just have it be maybe you can, but from what I can tell off of just doing this, you can't just have it be a bunch of a bunch of JSON like hash information. It has to you have to instantiate the messages here, right? Or else it's just not going to go. Because one of the benefits of JRPC is that you can just basically specify exactly what you want on either side of the wall. And if you deviate from that, the server or client will call you out on it, and then give you a really, really, really long, a really long mm, syntax thing. It's going to be really annoying to debug it. And yeah, so response info, new, success, true, node. We can just put the message there, and then we'll just keep filling this out until we have our ping response. We can just return that up. Simple as that, but it wasn't simple to figure out. Yeah. But this is just for a one-way call, but there are three other types here. You can have a remote procedure call where where the requester is sending a stream of data and the responder is going to send one item. You can have a remote procedure call where the requester is sending one item and the responder is going to send a stream of items. And then you can have a remote procedure call where the requester is going to send a stream of items, the responder is going to send a stream of items, and it's just a bidirectional two-way continuous communication until the conversation ends. To be completely honest, I didn't do the last one, but if you go to my, but if you go to my README, I linked all the major sources that I found helpful down here so that um anyone else that wants to look into it could also look into it themselves here. What I found the most helpful for the explaining the bidirectional stuff was I believe it was this link right here, Docs Languages Ruby Basics, which goes over an example where they're instantiating a server client connection that's basically talking about points in the grid, and then you can like draw a rectangle on the grid, and then you can say what items are within this rec space that the rectangle occupies, and then it's just stuff like that. So this I found really helpful for actually breaking it down. Let me close this now. Uh, so I apologize for the length of this video, by the way. This is very informal. I apologize. Um, so let's show a example where you will have streams of data. I'll only show like examples where there's only one side because I only kind of wrote the examples where there's only one side. But yeah, let me delete this because I shouldn't be touching this yet. If I touch this, I'm going to stay up until 2 o'clock in the morning trying to finish it out, and my girlfriend is going to be mad at me. I will not blame her because we supposed to be. Um, let's see. Um, data server. Here we go. So let's see. Let's clean this up. Um. Since it's a data server, we see that we're using chunk transfer services, so we're going to open that now. Please go back up. Thank you. Um, name node services. Close that. Okay, not okay. Okay, so we're back in the name node service. What we just looked at was only one of the servers. Now, granted, I could name this better. In reality, this is really just a service that I am providing to to the name node, which it could like add to the server to handle. So I should also rename that, but I will do that later. For now, let's look at the data server, data service. This now, one thing you should note is that you can have this and give it whatever name you want. The name will not matter. It's just going to be it's going to be it's going to be a child class of the service class within this and this. So I just name it something that's useful to me so that I can know exactly what's going on when I say I want a data server, I know what's being used right here. So with the data server, I initialize it as a parent, and the only reason I wrote both of these out is because, well, one, I was actually developing this, and two, I needed to make sure I could actually get this to work. Um, this receive chunks, if you recall, earlier in the video, I said that I like to write rote procedure call names as if is in a sentence where the word server comes before it. So if you say it out loud, the server will receive chunks of data and is going to return back a received chunks response. That makes sense. So we're receiving chunks, which implies we're going to get a stream of chunk data from the requester. This is how you do it, or at least how I was able to get it to work, right? So you have session info right here. So in this case, what I envision the code doing is that parent's going to handle all the logic, so I can procrastinate that, but it's going to basically take in all the streams, and then once that stream is done, it's going to create a received chunks response. The parent's going to do that, and then pass it back into the service, and the service is going to have the job of formatting the information into a response right down here. Now, to handle the fact that it is a stream, you're going to just define something that says call. Now, I believe you don't have to call it call. I call it call because that's what I saw in the tutorial I used, but call is basically going to represent the actual stream itself. And each remote read is going to represent, okay, this is what I'll do for every single chunk or every single message that I get during this remote procedure call stream. Now, in Ruby, how I handled it was that I each remote read, I wrote do. Chunk data is going to be the variable name for whatever message gets in here, and I'm going to assign the session info to the ch from the chunk data session info because what I want to do is that I vision there's going to be a lot of different communication going on, a lot of different files being exchanged and sent and replicated. So I want to be able to maintain a session info state that I can then use to tell the parent about later, and then the parent will ideally have some sort of like hash table about what sessions are active and be able to use this to figure out how it should send the it should basically put the information in for the response, right? So parent's going to handle that. And then once the parent handles that, you see that everything ends. Now, end is just how Ruby handles handles like structures like this. But this will signify that the stream is ended, right? And once the stream is ended, you're not getting any more data from that. So once this is done, it's then going to act you then have to actually do the whole return receive chunk response thing here, right? So what it's going to do is that it's going to create a response from what the parent sends down. Is you see how every bit of the response has to be instantiated first if it's a message of its own right. So the response itself is just response info, chunk information report, and chunk success. However, chunk info, the chunk information report, and the response information have to both be created. Now, since this is a chunk transfer service, let's open the proto file, put it up here. You see that we're using response info. So let's also open the core messages. Response info is up here. We have response success, which is going to basically be a Boolean. I can get that I can get that from whatever is in the response, which is here. I just copy, good practice, just copy and paste the name, so you're just getting the same thing, you know. The key for response success is going to be a response success, new response. Yeah, that response message, same thing right here. Um, they have new chunk info report, right? Now, if we go down here, we see that this is chunk info report, and if we go to chunk transfer, that is right here. So in receive chunk response, chunk info report is supposed to be a repeated chunk info. The repeated keyword means that we are expecting, and this is by definition, because I had to read this multiple times, zero or more of the message in question. So the message in question is going to be chunk info. So we're expecting zero or more chunk info, and how that gets understood when converted to JSON or another language is basically a list. So we're getting a list of chunk info messages, and chunk info messages are up here. So remember, we have to instantiate, right, this this object before we can actually pass it in, or grpc is going to throw a fit. So that's what we do right here. We create an empty list, and then we're going to iterate through the check report because we're expecting a list of some object. In this case, the object is just going to be another dictionary slash hash slash JSON-esque object because I'm lazy. Chunk ID is going to point to the chunk ID in the specific iteration. The same thing for chunk checksum and is last chunk. Now let me plug in my battery because that needs to be plugged in. Give me a moment. You ever just plug in your charger into a wall, but you're doing a blind, so you don't see anything? Yeah, that's just what I was doing right now. So this creates a list of chunk info, and we're just growing the list as we go through the chunk report. So now we have a new chunk report, which is going to be a list of the chunk info and our response info. Luckily for us, the last thing is just a list of Booleans, which we can probably just make in the parent because we're not really working. So we can just do chunk success. We would just expect the list of Booleans to follow in here. And this will be our response, which we will return. Now, if we were doing it the opposite way, where we will be sending a chunk request and well, the requester will be sending one item, and then the service will be sending a stream of items. This is how we'll do it here. So we have a similar structure to the single item exchange part. You just have one thing. Now I have this bit more detailed, which is why I think you don't the names of anything besides this call bit doesn't matter. So send check request, right? We're going to actually send this request to back up to the parent. The parent's going to take care of it for us, and the parent is not going to actually do the work of sending the information to the requester, but is going to send us the information in a list that we can then use to send stuff to the requester. So we get information in the list. Now, the important part about having a service which takes in one message and sends out a stream of messages. In this case, you're not going to really be doing a return. Returning will end the program early. So you need a way to actually definitively, I guess, quote unquote, return some item without ending the function where it's returning from. So that's where yield comes in. There's definitely a better a way to explain that. But what yield will essentially do is do the job of return for us without ending the loop early, so we can actually like send every single chunk to the requester. Uh, so so same as before, we have to make sure we instantiate every single every single RPC message format, right? So session info, we're going to send the session info. We're going to send the chunk info. So we're describing what the chunk we're doing, we're sending. And then we're going to put all that into a chunk data message, session info, new chunk info, the data itself, and we're going to yield it out to the requester. So I guessing the important part here is that you so yeah, I think this is just the easiest way to like handle something like this. Create a list of what you want to do, and then iterate through that list using each. And then every time you finish setting up your message, yield it out. And then just loop through that list. Simple as that. How they did it in the example was very confusing and actually made me doubt this code because they had a really convoluted thing where they had a yield, but they had a conditional yield. So they added a whole bunch of other stuff. But this seems to be to me, the simplest way to do it. Um, and that's basically it for writing this out. Um, Now it's not it for the video because we now have to get into the client side of things. So let's say you're me, and you want to make sure this worked. One of the things you had to do is actually kind of connect everything together to ensure that it works. So we're going to close this. We're going to bring up testcon local. You might have noticed this here. I kind of skimmed over it, briefly explained it. But now we're going to have to actually follow this path to make sure it works. So we're going to create a test chunk. Remember, we have to instantiate stuff. So we have to import this, right? We have to create the session info, and then chunk data. That's going to all go into chunk data. And then there's going to be a list. So what do? All we need to do to now activate the stream that we plan to send to the server is just do each. And that's it. It will just yield everything for us. And I know that, or at least I can assume that because it works. So we're sending it to a connection, which is a chunk transfer service at localhost 1138 with the credentials. I'm going to talk about the credentials later. Credentials were a pain in my butt, right? But we're going to do that. So that means that we can look in a service which falls under the chunk transfer service. Like for us, this falls under the chunk transfer service, so we can use this to actually see what we're talking about. So let's see, receive chunks. That is the remote procedure call that we're looking for. And you see how when I talked about how, you should name your calls as if it's in a sentence. So watch this. We're gonna get a response. Wait, I'm gonna save this for last actually. We the server is going to receive chunks of data from us iteratively, and after it's done, it's going to send a response back to us. Yeah, that works. So yeah, let's look for the receive chunks remote procedure call right here. Let's go to name node data server. This parent thing is going to kick in later though. Trust. So receive chunks is right here. So we have a each and we have a call. Now for each remote read right here, each, a nice thing to remember. We're going to we're going to handle chunk data iteratively, right? Save the session info, and then handle the receive chunk. Now, this is a parent function. So if we go back to the name node and we see that it's empty. Why is it empty? Because it does not matter for the purposes of me testing the connection. So we're going to pretend that we did some fancy stuff there, right? And we're going to end our stream, and now we get to work with the important part, the response. Now, I did have to write this out because, we actually need a response here. If we send nothing back, it's not going to work. So let's go back up to the parent. So let's go to the parent. We're expecting to get the session info and receive check response, right? Now, as you can see with the session info, we do not use this. Why don't we use this? Because it is not important for the purposes. It's not important for the purposes of this test. What is important though is that we get the expected format that we want back to be able to create all these messages that we can return. So what I did was I created a little testing here. It's going to return is going to return a JSONified hash where it's going I'm going to have a true for the response success. Um, the message is going to be that the test response was received successfully. And then we're going to have a chunk info report, which is going to be a list of a bunch of smaller key value pairs where the chunk ID is going to have a chunk ID, a chunk checksum, and it's the last chunk, right? This might look familiar now because this was in the output for the test I did, right? So you see response success, if we go here, that's true. Response message right here. And then we have a chunk info report. You see that little I forgot what this is, what it's called. I'm blanking so hard right now. This is embarrassing. But that is the listing bracket. There you go, bracket, right? So we're going to have a chunk transfer chunk info struct where the chunk ID is going to be 0, checksum, and last chunk. And then we're going to keep going the list of structs right like that. And then once it gets there, we're going to have our chunk success, which is going to just be a list of truths because I am never wrong, right? So so once we return that, we're going to follow this back up here, right? We're going to have a response here. Now, so let's put this right here. We can close this because I proved my point. And we're going to now walk through the code and see how it turns out. So we're going to say we're going to, in our response info, we're going to set our response success to new response success, which is right here. We're going in for our response message, we're going to set it to new response message, which will be right here. For our chunk report, we're going to iterate through the chunk report because it's a list right here. And for each chunk report, which is the individual chunk right here, information right here, we're going to have chunk info, which the chunk ID is going to be set in the chunk ID right here. The chunk checksum is going to be set to the chunk checksum, which is right here. Then the last chunk is going to be set to the last chunk, which is right here, right? And we're going to do that for this, this, and this. And now we're going to have a chunk success, which is going to be just to be a list of chunk successes because these are primitive data types that we could just send out and it'll be fine. And when all that's said and done, we can finally put all the information into a received chunk response and then return it. And once we return it, we'll finally go back to here, where we get this response, we kill the server, we print it out, which is how we get this. I love when a plan comes together. Right? So, let us, this warning message, I'm guessing, I kept getting it, but what I'm guessing is happening is that since I killed the server, I'm killing the server before I can fully print out this warning message. So, nice there. Uh, mm, excuse me, I had a small burp. But, so we just walked through that, and now we have a bona fide Ruby structure. But wait, there's more. So all keep in mind, all this works if you simply just have a stub that is an insecure connection. Often when you see tutorials for this, you'll probably see something like is insecure in insecure connection, right? Now that is because now when it's an insecure connection from both the stub and if we go to the name node, um, this name node, that will basically indicate that we are not using TLS. But what if you were an overachiever or you were just purely curious because, you want to be a good programmer, right? You want to actually if you show this to someone, you want it like someone that's probably going to hire you, you want to show that yes, not only can I code in gRPC, I know how to make a secure connection with it. Well, that's a whole new world because this looks really simple to figure out, but it took me a while to figure it out because I do not understand how the channel connections work. I don't understand how server credentials work because if you because if you go one, there are not many projects that actually use Ruby at for doing gRPC. That's one thing. A lot of the projects you see are in Go, in Python, in Java, in C, other languages. So it's hard to find examples of that already. Two, which is actually why I actually started linking the examples in README because I got so desperate that once I actually found something, by the way, what I found was this GitHub page right here. I had to make sure I linked it to make sure I remembered what I found, right? Um, but yeah, once I let's go here and let's revert. Now, say you want to actually add a TLS connection. Here is what you have to do. So, first you have to establish that you want it at the server side. So here are the options for that, as I can tell. You first have you first have the root CA that you want to share, right? The root CA is going to be what signs off on the certificate and key that your server is going to use. If you do not specify a root CA in this first item, then what server credentials is going to do is going to assume that you are you are using a self-signed certificate. That is fine. You are able to do that. But if you try to when you try to connect to from your client, you might run into issues there, which is uh I don't know how you can, but I digress. I digress, right? As you can see, you see simulation CA server certificate. I'm going to get into what that means later. Now, name doesn't matter for the certificate actually, because I'm just reading the certificate in, and whatever I read is just being just put into here. Okay, so that doesn't matter. That does not matter. Don't think that matters. I promise it doesn't, right? Neither does this or this. Look, it's going to accept the string. Trust me. So then after that, you will have a array here where you will put you will have a struct or a dictionary of a list of structs slash dictionaries. Excuse me, I'm sorry, I'm gassy today. Struct slash dictionaries, right? You'll have your private key, and then you have your certificate chain. I'm guessing for the certificate chain, you can have a list of certificates here, but in this case, I just have the one because I'm not doing all that. And then you have true. What this true represents, because if I try to like find the highlights or even the documentation, you cannot find this. I don't know why. Is this indicates that you want to create you want to create a mutual TLS connection or mTLS. What mTLS is that not only it is the server going to provide you their certificate, but a client is also going to provide you their certificate. There's a problem with that though, because because of the simple fact that I cannot find where it describes how you should formally do this. I had to rely off of examples and trial and error to figure this out. So I don't know what the intricacies of this class is fully. But what I did figure out is that if you're going to go the mutual TLS route and you're going to supply a certificate and key pair for the client side too, you have to use the same certificate authority certificate or you have to use one that both ends can recognize, or else neither is able to um, really authenticate the other. Um, so you see the formula here. So root, as a reminder, if you make when you're making server credentials, right? You have your root certificate. You add the certificate of the server you're going to do it from yourself, and then you can decide true or false for if you want to have the client authenticate too. I'll say have the client authenticate too because why not? After that, you have if you're doing it from the client side, right? Notice here, this is server credentials, this is channel credentials, right? For client side, you use channel credentials. You're going to have first the CA certificate that both of you are going to share. You're going to have you're going to have the interface. You're going to have the key and certificate of the client here. And for both ends, you're going to pass that information into the ports. In this case, when you're for the server, when you're adding a new port, you pass it in. For the client, when you're creating a new stub, you pass it in here. And that was hard to figure out. I know I'm saying that a lot, but the whole reason why I'm making this video is because of how convoluted I had to look around the internet. Like I was on Stack Overflow for a hot minute. I got so desperate trying to figure out this specific part of the code that I actually started hunting through the source code for the Ruby grpc library. And it wasn't until I found that godsend of a GitHub that I figured it out, and some other stuff quickly after. I'm making this video so that even if it's very convoluted, it's here. It's here. So I really want people to know. I'm going to put it in the I'm going to put it in the name of it so that if anyone else has this problem that's really obscure, you can find it. Um, let's see. What else? What else? So, but that's basically that. There's one more thing I will talk about, and that's the generate setup. I want to specify the specific setup that ended up working to do this, right? So, because I'm making a Kubernetes-based project, I'm using a configuration file, but just so people know, this is how I was able to figure this out. This probably works with other certificate configurations, but this is what I use. I use a TLS RSA key size. I use RSA for the key, right? Uh, I use a key size of 2048. I use a certificate version of 2. There's certificate version 3, but I'm not sure that Ruby's there yet, so I'm leaving it alone for now. I'm using a certificate serial length. Well, this doesn't matter. Honestly, if you go to generate setup, if you go to generate setup, right? And you go to where is it? I believe I forgot where it was. Here it is, right? Certificate serial where you're saying what you want for the serial. You can honestly just put 0 or 1. It kind of does not matter. I'm doing it in a more professional way, so it looks a bit more realistic. But if you want to know what length I have for that, it's 32. I'm auto-generating a random number with 32 bits, right? For the validity days, I use 30, but you can use anytime you want. I just use 30 because I don't need to have these certificates up for a year. That's OD, right? Um, the digest hash, I'm using SHA-256. I specify here that you should go here to make sure you're writing what hash you want correctly. because this library is basically just a wrapper for the o Open SSH utility. So we go here. I'm reading it in here, and passing the digest hash into here, right? Um, yeah, those are the main settings. Um, if we go back to here, we do note that I did have to use a CA certificate to figure this out. Now, you probably can have a larger hierarchy where you can have things in their own different domains, and then you can have even higher domain on top of that, where the true root certificate is. But what I do know is that it has to be a root certificate. It has to be something that could be traced. It has to be some sort of like common ancestor type thing that both sides can trace, or else it's just not going to work. So what I did is that if I go down here, I have a certificate of authority that's just going to cover the entirety of the simulation. And everything's going to point that back to that certificate of authority. I can have a bit of a domain hierarchy, but it has to be a unified certificate of authority, at least for me to get it to work. And I could probably figure out another way for it to work, but I haven't put so much energy into this already that I'm not going to. So this is what I did right here. If you're wondering what the code does, I want this to auto-generate a bunch of stuff for me. So what this spit does is that it's just going to create the key and certificate and to save it to where I want it to save it. In this case, it's going to save it to setup location, which I get from here. If I go from here, I'm saving it to this folder, and this folder is right here. If I open this, you see all the keys and certificates here, right? So um I don't know what else there is to it. I think that's about it. So, thank you for watching this video. Um, I'm going to try to section it so you'll be able to try to track where my ramblings go. Uh, like, subscribe, or don't. Honestly, I just want to have something out there where it's easily findable by keywords, and that if you're ever wanting to do Ruby, auth Ruby and GPC with TLS, then this is the video for you, or it kind of is. If it gets enough views, I can make a better version of it, or you can make a better version of it. Um, yeah, it's 12:31 in the morning. Have a great morning, evening, night, wherever you are. Be safe out there, and yeah, thank you for watching.